This is geometry lesson 3.8. We're going to be looking at perpendicular lines. So the big idea says lines containing the rays of a right angle are perpendicular. All lines perpendicular to the same line are parallel. So we'll break that down here as we work through the notes. So the definition of perpendicular says two segments, rays, lines are perpendicular if and only if, so we got a biconditional here definition, if the lines containing them form a 90-degree angle. So if you have a ray, it is perpendicular if the lines containing them form a 90-degree angle. Remember, biconditional can be read both ways. So if the lines containing any two rays, segments, lines, form a 90-degree angle, then they are perpendicular. You can read it either way. Okay, so if you have a 90-degree angle, the lines that are crossing and intersecting to make that are called perpendicular. So at the right, we've got angle ABC, and it is a right angle. You can see the markings in the picture. So we can say that line M and line N are perpendicular. So the symbol for perpendicular looks like this. It's just two lines hitting at 90 degrees. That symbol is red, perpendicular to. So you can write that line M is perpendicular to line N. You can use the other notation with the points on the line. You can say line AB is perpendicular to line BC. That's the same thing. You could even mix and match. You could use line M is perpendicular to line BC. Okay, so you can name the lines any way you want, but this means perpendicular. Now, you can never assume that lines are perpendicular unless you see the markings for 90 degrees or you're told in a given statement that they are perpendicular. Now, we've talked about vertical lines and supplementary lines. So if we've got two lines crossing at 90 degrees, this angle is going to be vertical to this angle. So they're going to be equal. So this angle also has to be 90 degrees. We also know that these angles next to each other add up to 180. So if this is 90, 90 plus another 90 is 180, and that's vertical to this one, which will also be 90. And all four of these together have to form a full circle. 9 times 4 is 36. 90 times 4 is 360. All four of these angles are going to add up to 360, 90, 90, 90, 90. Okay, so when intersecting lines form one right angle, the vertical angles in linear pair theorems force the other angles to be 90. So once we see a 90-degree angle, we know all of these are going to be 90. Okay, a couple theorems here. Two perpendiculars theorem says if we have two lines, this is just giving them a label, L and M, two lines are perpendicular if two lines are perpendicular to the same line, so a third line. So we have two lines, they're both perpendicular to another line, so it's going to be demonstrated here in the picture. Let's label. These are your two lines, L and M. We've got this third line, and both of these lines hit that third line at 90 degrees. So this is what they're talking about here. So if L and M are perpendicular to the same line, then they are parallel to each other. So if we see these two lines hitting another line at 90 degrees, both of them are perpendicular to that other line, we are allowed to assume that these are parallel to each other. And there's the parallel lines marking. So even if they're not marked parallel, if two lines are hitting another line both at 90 degrees, we know that those lines are parallel. We're allowed to now assume that. Okay, the next theorem is just going the opposite way now. So if we have a line that's perpendicular to two other parallel lines, then we know that it is perpendicular to the other. So what that's saying is now, over here we were given two 90s, and so we were allowed to say, okay, these lines must be parallel. Over here, we're given that two lines are parallel, so we automatically know if this is 90, this is also going to be 90. Those are corresponding angles, we know that. Okay, and then the vertical angles would also be 90, and these would be 90. But since we have parallel lines, and we see that one of those two lines, the M, is perpendicular to L, we know the other one is also going to be perpendicular. So it goes both ways. So basically, parallel lines both cut by the same transversal. If they're perpendicular on one of them, they're going to be perpendicular on the other. All right, and this is very, very important. We've talked about parallel lines having the same slope. There's something special about the slope of perpendicular lines. So parallel lines go the same amount up and down. That's the slope. perpendicular lines, the one that's crossing them, clearly has a different slope. It's going a different direction. So they're not going to have the same slope. So two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Product means multiplication. So the two slopes of a line and another line that hits it at 90 degrees perpendicular, the two slopes are going to multiply, have a product of -1. So if the slope over here was 2, and I multiply it times this other slope, I have to get -1. So if I'm multiplying that to get -1, I would have to multiply by -1/2 to make that happen. So let's look a little closer. The slopes of two perpendicular lines are always opposite reciprocals. That makes them multiply to -1. I think, personally, trying to figure out the number that makes it multiply to -1 is more difficult than just thinking of the opposite reciprocal. Reciprocal is when you take a fraction and you flip it. So if you had 2, you would flip it. It's like 2 over 1. The reciprocal is 1/2. The opposite reciprocal makes it -1/2. So if you look at what we've got here, the reciprocal of 2 is 1/2. The opposite reciprocal is -1/2. And we already showed that that multiplies to make -1. You would get -2 on the top, you'd get +2 on the bottom, and that simplifies to -1. So instead of trying to break down with some mental math, what do I got to multiply by to make -1? Just know that it's the opposite reciprocal. You flip the fraction, you change the sign. Opposite means change the sign, reciprocal means flip the fraction. So for example, the opposite reciprocal of 4/5 is -5/4. I flipped the fraction, I went from positive to negative. The opposite reciprocal of 7, -7, I'm sorry. We know that it's over 1, so we flip it, it's 1 over 7. Negative becomes positive. If I multiplied straight across, I would get -7 over 7, and that would be -1. Over here, I would get -20 over 20. That would make -1. We've already done this with the -1/2. You flip it, it's 2 over 1, make it positive, so it's 2. -18 over 5, the opposite reciprocal, flip the fraction, change the sign. Okay, this is what the slopes are going to look like for perpendicular lines. One of them is going to look like this, one of them is going to look like this, and that's how we know they're perpendicular. So parallel is easy, they have the same slope. Perpendicular, the slopes are going to be opposite reciprocals. So let's take a look at this. If we're on example 1, we want to find the slope of a line that's perpendicular to this one. So this line has a slope of -2/3. If we were looking for a parallel line, the other line would have a slope of -2/3. But since we're looking for perpendicular, we need the opposite reciprocal of -2/3. So it's going to be positive first of all. And we have to just flip this. So it's 3 over 2. And that's it. The opposite reciprocal of -2/3 is 3 over 2. The fraction is flipped. Negative becomes positive. If I multiplied these, 3 over 2 times -2/3, I get -6 over +6, which is -1, which fits my theorem. Okay, so the slope of a line perpendicular to this one with a slope of -2/3 is going to have a slope of +3/2. Let's take it a step further. Example 2, write an equation of the line that passes through this point and is perpendicular to this line. So given a slope and a point, we've already worked through these types of problems to write an equation, and I will refresh your memory. But the first thing we need to do is make sure that our slope that we're going to use creates a line that's perpendicular to this one. So right now, the slope of this line is 4 over 1. A perpendicular one, the opposite reciprocal, you flip the fraction, it's 1 over 4, and you make it negative. It goes from positive to negative. So the new slope, y equals mx plus b, for our line L, we're going to write a new equation for this one. The slope's going to be -1/4. So we're going to drop that in the slope spot. And we can't leave it like this. We got to finish off the equation. If it's going to go through 0.23, we can substitute in those values for x and for y, and then write our new equation once we know what the intercept is. So let's go ahead and plug in. The y value is -3. The x value is 2. And we're going to go ahead and we're going to find out what b is. So first thing I should do is multiply 1/4 times 2. You might be able to do that in your head. It's a half, or 0.5, and it's a negative times a positive, so it's going to be negative 0.5 plus b. All right, so I'm going to have to add 0.5 to both sides to get rid of it, and now b is going to be by itself. So b equals, and if you do -3 plus 0.5, you're getting closer to 0. That's going to be negative 2.5. So that is your b. And now you go back and you write the original equation in this form, y equals mx plus b. That's how the other line was given to you. The slope we said was -1/4, and we just found the intercept to be -2.5. So you write y equals, we're not plugging in these numbers, that's for one specific point. We want the equation of a line, so for all points. So we leave it a y, we leave it an x. The slope is -1/4. The intercept is -2.5, so minus 2.5. And you now have the equation of a line that passes through this point and is perpendicular, has that opposite reciprocal slope to the line y equals 4x minus 1. All right, and so we will try a bunch of these in your homework. So a quick summary of parallel and perpendicular lines. When you have a point, it marks a location. It's given by an ordered pair. Okay, we know what a line looks like. Equation of a line. The measure of the tilt of a line can be measured with an angle measure. So if we have two lines that are meeting, okay, the angle is going to dictate the tilt of that line, but we can actually find the slope if it's on a graph, and that measures the tilt. Parallel lines, the corresponding angles are equal in measure. So if there was two angles and they created parallel lines, those angles would be the same. But more importantly, the slopes are equal in parallel lines. Perpendicular lines we know form 90-degree angles, and we just talked about the product of those slopes is -1, and they are opposite reciprocals.